So the very first thing we discuss in kinematics is the definition of distance and displacement. So here it is our x, y, z coordinate system, and in this coordinate system there is one object, one particle which is here at the point A, and this is the position vector of this particle. Do you remember this thing, position vector? We learned about it in vector algebra. Alright, position vector and displacement vector. And I warned you at the time of teaching vector algebra that without vector algebra you can hardly do anything in physics. So I suggest that if you are still having some confusions, then go through the videos once again and watch them carefully and clarify your concepts, because vectors is going to be used very extensively. Alright, so here it is the position vector basically of this particle, the initial position vector. And usually we are given the coordinates of the particle. So here point A, x1, y1, z1 is the initial coordinates of the particle, and this particle follow a particular path and then reaches. So here it is another point B. Alright, so another point B, and its position vector is say R2, and just assume that x2, y2 and z2 are the coordinates of the point B. Alright, and the particle is following this particular path and reaching here. And if we join the starting point to the final point straight, and a vector which starts from the point A and towards the point B, this particular vector is what? The displacement vector. Alright, it is the displacement vector of the particle, which can be represented as delta S. Alright, so here point A, here is another point B, x1, y1, z1, x2, y2, z2, and here it is the R1 position vector of A, this is position vector of B, and here the delta S vector is what? Displacement vector. Delta S vector is displacement vector, and using the triangle law of vector addition, we can easily write that R1 vector plus delta S vector is equal to the R2 vector. That means delta S vector is equal to R2 vector minus R1 vector. That's it, of a particle. So here the distance is actually the actual length of the path followed by the particle, and it's a scalar quantity, and units of measurement are meters, etc., that you already know. So distance is the actual length of the path and a scalar quantity. There is no sense of direction. But displacement is a vector quantity, and its magnitude is the shortest distance between initial and the final point. Alright, the shortest distance between initial and the final point is the displacement magnitude, and its direction is always from a starting point towards the final point. Alright, you have to remember this, that in any type of example, the direction of displacement vector is from a starting position towards the final position. And here we are representing it with this symbol delta S. So here, knowing the coordinates of the particles, we can always write the position vectors like this: x1 I cap plus y1 j cap plus z1 k cap. Alright, and in the same way we can write the second position vector of this particle, of the same particle which has moved from the point A to the point B. And R2 minus R1 is the change in position, which is basically the displacement. So using that, we can write the displacement as x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So in terms of coordinates of the particles, if you are given with the coordinates, then you can easily write the position vectors and as well as the displacement vector. And suppose you are asked for the magnitude of this displacement, that you can always tell that it is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Alright, it is in fact the formula in coordinate geometry also, and here you can clearly see that it is under root of x component square plus y component square plus z component square. The distance is a word which we normally use in our day-to-day life, but displacement is a certain technical word. Now let us solve one problem based on this particular concept of distance and displacement that we have learned just now. The displacement of the point of the wheel initially in contact with the ground. So here it is a point which is in contact with the ground. You can visualize the ground level here at the bottom. And when the wheel rolls forward half a revolution, then where r is the radius. So when wheel rolls forward half a revolution, we have to find the displacement of the point of the wheel initially in contact with the ground when the wheel rolls forward half a revolution will be. We have to select one of these options. So what it's saying that it rotates by half revolution and moves forward. As you know that in one complete revolution, this wheel forwards by a distance equal to the circumference of the wheel. Alright, so in half revolution, it will move by a distance half the circumference. So circumference is what? So distance traveled in this case will be half of that. So 2 pi r divided by 2. So half of that means pi r will be the distance traveled by the center of the wheel. But it is talking about the point which is in contact with the ground. That you can see that as this wheel rotates by half a revolution, so it reaches here. Alright, it was here. Okay, it is the initial position of the wheel, and this particular point has moved to this top point in half a revolution. So everyone must be agreed to this. Alright, so this point has reached this location and we have to find the displacement of this point. So you can clearly see that this length is pi r, and of course this is the diameter of the wheel, which is 2r, and we know that displacement is a vector quantity and its magnitude is the direct separation between the starting and the final point. The actual path followed by this particle is somewhat this type of a path must have been followed by this particle. Alright, but we are interested in the shortest distance between its initial and the final position. And as a vector, it has got direction, and this direction is from initial point towards the final point. So displacement of this point delta s is equal to the shortest distance, and that we can calculate using the simple Pythagoras theorem. So pi r square plus 2r whole square. So displacement is equal to r under root pi square plus 4. So option B will be the correct option. Alright. There is another question in which an aeroplane moves 400 meters towards north. It's saying that this particular aeroplane moves 400 meters towards north and then 300 meters towards west. Alright. So as we can see that east is here, west is here, north and backside is south. Alright. So it first moved 400 meters towards north and then 300 meters towards west and then 1200 meters vertically upwards. Then its displacement from the initial position is, in this we have to find the displacement. So how this plane is moving, first goes towards north and then 300 meters towards west and then 1200 meters vertically upward. So first of all, you can see here that this distance is 400 meters and here it is the 300 meter distance. So this particular angle is 90 degrees. Alright. So this is a right angle triangle and we can use the Pythagoras theorem here to find this particular distance. Alright. This direct distance. But we are asked for the displacement, the final displacement, which is the distance between, shortest distance between initial point and the final point. So here it is how to find it. So this particular distance is being asked. So how to solve it? As you have clearly seen that this plane has moved 400 meter towards north first, and then 300 meter it turns to the west, and then it finally climbs up to 1200 meter above the ground. So here you have clearly seen in this video that this particular angle is 90 degree. So this length, say it is x, so x becomes under root of 300 square plus 400 square, alright, and everybody knows that it is 500 meters. So x is 500 meters. Suppose the displacement of the plane from this initial position towards this final position, and its direction will be like that. So displacement will be what? Now we have to treat this right angle triangle. Here you can see that this vertical line and this line on the horizontal plane, both of these lines are 90 degree to each other. So this distance is 500 meter and here it is 1200 meters. So delta S becomes under root of 500 whole square plus 1200 whole square. Alright. So its value is 1300 meter. Alright. So 1300 meter will be the displacement of this aeroplane. Alright. Here a body moves over 1/4 of a circle arc in a circle of radius r. So here it is a circle of radius r. This is radius r. The magnitude of distance traveled and displacement will be respectively 1/4 of the circular, means from here to there. So it is 1/4 of the circumference. If we are to calculate the distance traveled, then we have to find the actual length of the path. So distance becomes what? 1/4 of the circumference of the circle. So it is what? Pi r by 2. Alright? Pi r by 2. And then displacement. Displacement will be, clearly you can see this is the displacement. Alright. So displacement is what? R under root 2. Okay. So here actually the R should come. So first option will be the correct option. Here it is a circular park, has a radius of 1 kilometer. This circular park has got radius of 1 kilometer. So here it is 1 kilometer. A man is standing from the center of the park, somewhere here. A man is standing from the center of the park, walking towards east. East means this way. We are assuming east, west, and here it is north and south. So this is our horizontal plane. So he says that man moves towards east and going the circumference of the park, going around the circumference of the park, reaches the north gate. Here it is somewhere north gate. Then what is his displacement? So displacement, as we know, that it is the shortest distance between the starting and the final point. So it doesn't matter how the man has reached this point, but we know that displacement is this, only 1 kilometer. So as we know that displacement is the shortest distance, independent of the path followed by the body. Okay. So next question, here it is, an ant start from one corner of a cube of side length 3 meter. This is a cube of side length 3 meter and reaches the diagonally opposite corner here. Suppose it starts from this point and reaches diagonally opposite corner somewhere here, opposite corner. So we have to find the displacement. So as you can see here that inside a cube, clearly see that this line, both are perpendicular. So using these two lines, we can find its value. It becomes what? 3 root 2. And then here it is the vertical one, because it's reaching this position. So here it is 3 root 2 and this is 3 meter, because side of the cube is 3 meter. So, and this particular triangle is also a right angle triangle. So 3 root 2 square and 3 square under root. So what should we getting the value? So here you can see that if suppose A is the side length, so A will be this, A will be this, and here it is for this right angle triangle, this particular face diagonal is what? Hypotenuse. So this becomes A root 2 and this is A, and we have seen it clearly that this angle is also 90 degree. So the net displacement of the ant will be equal to under root of A square plus A under root 2 square. So it becomes what? A under root 3. So it is 3 root 3 meter is the displacement of the ant in this situation. So now we'll be discussing about the speed velocity terms. Okay.